Hello everyone. I just wanted to go over 3.1 just a little bit more in detail for page 2 and point out that I did make an addition to page 1. One of those additions is up here. I wrote down another exponent rule where anything to the 0 power equals 1. So a to the 0 power equals 1. Thus, if we have 2 to the 0 power, that equals 1. So when we're plugging in this equation, 2 to the first power, that equals 1, and that gives me 4 times 1. And that's how I get a 4 here. I didn't get to point that out earlier today, but I thought it was important to add that to the lesson. Everything else on this page is the same. Travis down here, he's adding 0 and 1. Divide it by 2, you get 1/2. 1 and 2 divided by equals 3. Divide it by 2, you get 1/2, and so forth. So that's what he did. And what we did after this page was go to page 3, and we plotted all of these points, and then we plotted the extra points in between. So that is page 1. So let's move on to page 2. Just take me a second to get there. Edit, markup. Okay. So on page 2, we're missing number 4. Why is that? That's weird. Okay, maybe I just, there it is. So up here on number 2, number 4, I'm sorry. It says, comment on Travis's idea. How does it compare to the table generated in problem 1? Well, it doesn't match up for 1. And the reason it doesn't match up is because he created his points were linear. Okay, and that's why it doesn't work, because we're working with an exponential, and he was trying to find linear points, exact points on the graph. Just by doing the average like we did, that was finding linear points. So now we have Miriam. I'll just circle her name here. She has an idea. She wants to treat it exponentially. And in order to treat it exponentially, there are a few things I need to give you. One is the equation, or not equation, I should say, one of the exponent rules. And you could also call it a radical rule, but I think it's more, yellow's not going to work. It's not going to show up. Let's pick a different color. Okay, so the rule is b to the 1 over n. If I can make it look like an n. I'm using my stylus pen, and it's not always the easiest thing to work with, so you'll see me redraw things several times. And I'm going to remove my bracelet too. Okay, so b to the 1 over, try it for a third time. At least I don't have to use whiteout. b 1 to the n equals, that's 1 over n. That's what I'm trying to write. I'm trying to write 1 over n. Okay, it's not working out for me. And I tend to be a perfectionist with this stuff. 1 over n equals the nth root of b. Okay, so what that means, and if you remember, our original equation was f of x equals, I wonder if I can make this bigger. Nope. Equals 4 times 2 to the x. So I would have, for this one right here, I would have 2 to the 1/2. And what does that equal using my rule? And it's still driving me crazy that that doesn't look like 1 over n. 1 over n. Yay, much better. Okay, so I'm going to get my square root bracket ready. If we notice that the base b, or 2, goes on the inside, and then the denominator of the 1/2 comes here. Okay, so the denominator is inside the little root part, and that gives me square root of 2. So I would have 4 times square root of 2. One thing I hadn't done yet, oops. Let's go ahead and write in our other numbers, and we already had them. F of 1 equaled 8, f of 2 equaled 16, f of 3 equaled 32, and f of 4 equaled 64. And I'm going to go ahead and do that down here too. Just plug in my numbers, 8, 16, and this time it only goes to 32. So now, if this 1/2 is 4 square root of 2, what's happening is I'm multiplying by square root of 2. 4 times square root of 2, or 4 square root of 2 times square root of 2 equals 8. Because remember, square root of 2 times square root of 2 equals square root of 4, which equals 2. And that would give me 4 times 2 is 8. 8 times square root of 2 equals 8 square root of 2. And then I could just finish filling out the chart, 16 square root of 2 and 32 square root of 2. So that is number 5. I could also write exact numbers, and I am going to want you to graph this, and we'll graph them here in just a minute. But let's see, I'm going to have to erase just some of this. Okay, we get that we have to multiply by square root of 2. But I want to point out that 4 square root of 2 is, if I plug that in the calculator, is 5.65, and that'll help you graph it better. Number 3 is 11.3. 16 square root of 2 is 22.6, and 32 square root of 2 is 45.2. Now number 5 is done, and it asks, what did we use as a constant factor for number 7? What did we use as a constant factor in the table in problem 5? Well, we multiplied by square root of 2. So then in number 6, she wants to find even more values. She wants to find 1/3, 2/3, 4/3, 5/3, 7/3, and 8/3. So we have all these thirds, and it seems like it's going to be complicated, but in reality, now that we know that the square root will be 1 over n equals n square root of b, we can figure out what that would be. So let's figure out what that constant factor is. I have 2 to the 1/3. Because remember, we're still 4 times 2 to the x. Okay? Remember, 4 times 2 to the x. That's our base equation. So 2 and 1/3. The denominator goes inside the radical. I kind of lost the 3 there. And then 2, which is the base, stays inside. So now we have cubed root of 2. And I can fill out all the ones right after, like 4 times cubed root of 2 is 4 cubed root of 2, and that's going to be really hard to draw in that tiny space. Let me see if I can make it bigger. Not much. 2 cubed root of 2. Oh, and it's not 2, it's 4. Sorry. 4 cubed root of 2. And this one would be 8 cubed root of 2. And this one would be 16 cubed root of 2. Now we have 2/3, 5/3, and 8/3 to figure out. Well, we're going to use the space in number 9 to finish this. And this is where you are going to need another rule. So we have this one up here where b to the 1/n equals nth root of b. Well, we also have one, I'm going to call it a to the m/n. And that equals, we still have our radical sign, n still is in here, a still goes in the middle, or not in the middle, but inside the radical. And we multiply it m times. Well, it looks difficult, and I agree, it can. But once you practice doing it and using this formula, it becomes easier. Don't let the fact that Module 3.1 seems really hard. We're going to have a lot of practice with it, and eventually this should become very easy for you. So I'm going to look, in this case, since I have 2/3, I'm looking for 2/3 right here, okay? And I need to figure out what is 2 to the 2/3. Let me see if I can write that any better. There we go. So that would equal cubed root of 2 squared. And just like what we did up here, remember up here, square root of 2 times square root of 2, you get square root of 4 because we multiplied the 2 and the 2. You can multiply these with each other. Is there an undo? No, there isn't. Okay, I wanted to erase that circle, but I can't. So this would give me cubed root of 2 times cubed root of 2, which gives me cubed root of 2 times 2, or 4. And that's what I would put up here for the 2/3. I'd have 4, because I'm multiplying by cubed root of 2 again. What color can I put in here? Okay, so let me make this big again. So this would be 4 cubed root of 4. I'm sorry, that doesn't look much like a cubed, and I have to write over some of these. This would be 8 cubed root of 4, and this would be, oops, just trying to move it over some. Not working out for Miss Stallings. Okay, so 16 cubed root of 4. And again, it's really hard to write with this pen. I wish I had a smaller choice with writing, but I don't. Okay. And between each one of these, it asks, did you use a constant factor? Yes, we used 3 square root of 2 for it. And I'm not going to bother answering for x equals 5/3. We did the one for 2/3. But it would be the same for 5/3. I just don't have any room on the paper to do it. But I'd end up having 4 times, I might have a little bit. Oops. Ah, shoot. Ah, cool. Not as bad as I thought. Okay, so down here, if I did do 2 to the 5/3, doesn't show up very good, that would be cubed root of 2 times 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 cubed root of 2. And you'd have 5 of them. And 3 of them, which we'll talk about more in the next section, would make 2, which is why 8 times 2 becomes 16. And pretty sure, and then we'd have left over 3 cubed root of 4, because this is what would be left over. This part equals 2, this part equals cubed root of 4. I know that's kind of hard to see. So 2 cubed root of 4 times 4 is 8. So that'd be 8 cubed root of 4, and that's what we get up here. So let's go ahead and look at the last page. So I'm going to click, I almost want to take a screenshot of that. There we go. So I'm going to click done. I need to cancel this, discard my changes. I need to go back and let's look at the graph. And the stuff in red, oh, I have to edit it. Almost done here. The stuff in red, that is Travis's line. And now we need Miriam's line. So I'm going to do hers in purple. And hers, if we plot the points that we had for number 5, we were at 1/2, 5.65, which was about right here. And at 3/2, we're at about 11.3, so that's about right here. And then at 5/2, we're at 22.6. So that is 22, 23, 24, 22.6, I think is right here. I feel like I'm too high up. Let me look. Yeah, that's not right. Oh, it didn't even do it. So let me try 22.6. 3/2. Here's 22.6. So it's about right here. And then 7/2, which is at 45.2. 45 is right here, so it's about right there. Now if you look, Miriam's dots follow more with our original pattern, much more nicely than the others did. And then you could do 1/3, 2/3, 4/3, 5/3, and even get more of an idea. But I'm going to go ahead and try to connect the dots. Oops. I thought I pushed erase. There we go. Cool. Not the best graph, and you know, Miss Stallings, I have to have it perfect, so I'm going to come from the bottom down, or I mean the top down. Close enough. Nope, it's not going to work for me. Try one more time. I'll just come from here to here, and then here to here. But there we go. So that is the task. This is Miriam's line. And as you can see, her line is much closer to the actual exponential equation, and it looks like an exponential graph. Even if I put curves for Travis's line, it still would not match up to Miriam's line. And that is the task for 3.1. Remember, the homework is to finish the Ready, Set, Go. The Ready, I already gave you the linear and exponential equations on the first page of the notes. And good luck.